Yes, this is going to be the video for the binomial theorem. Remember, this quiz is optional. Again, if somehow somebody missed that message, you don't have to take it. Look over your grades and decide if it matters to you. If you already have an A, then there's basically no reason to take it. I would advise you not to take it. If you have a B, well, remember we are going to drop a grade, so make sure you've really calculated your grade. If I drop a grade, will that get you to an A? Maybe it will. Maybe you don't need this. And again, at the time that I'm recording this, I haven't finished grading your quizzes. I'm going to try to do that, but I thought this was the priority to get this out so that you guys could start studying. Getting all your grades done is, the next priority, obviously, and I'll do it as fast as I can. Anyway, I'm going to start teaching. So here I go. So again, with the binomial theorem, here's the deal. You want to be able to take this expression and expand it out. And what you don't want to have to do is to literally take an A plus B and another 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 1, 2, 3, 4. Yeah, one more. A plus B. Because you probably know that if we multiplied this out, you'd certainly get all 6 of those A's. You'd have an A to the 6. You'd get all of those B's. You'd have a B to the 6th at the end. But in the middle, you'd have every combination of everything else. I think that's something everybody did understand pretty well. Is we'd get another term that had 5 A's and 1 B in it. Then you'd get a term that had 4 A's and 2 B's in it. Then you get a term that had 3 A's and 3 B's in it. You get a term that had 2 A's, 4 B's. Erase. Then what? You'd have 1 A to the 1, B to the 5. And finally, you'd just have B to the 6th. And again, that's because your A is an A to the 0. So that's it. I know there's going to be this many terms. By the way, how many terms? But when you raise it to the power of 6, you get 7 terms. Look, 1, 2, 3, 4, 5, 6, 7. Again, it's 7 because you're not counting from 6 down to 1, right? You're counting from 6 all the way down to 0. That adds an extra term. There's 7 terms. So what else, though? This isn't it, right? We know that in this expansion, there's going to be coefficients here, too, because we saw in an A plus B squared. We should all have this memorized, by the way. It's a squared plus 2 ABs plus a B squared. It would be nice if you had an A plus B cubed memorized too. It would be an A cubed plus 3 A squared B's plus 3 AB squared plus B cubed. Now where are those numbers coming from? Well, they come right from here, from Pascal's triangle, right? We know that here what we're seeing is the expansion of an A plus B to the power of 0. So annoyingly, that first row is again really the 0 row. Just like the first B in this first term isn't B to the 1, it's B to the 0. So next you'd have AB, A plus B to the 1. A plus B to the 2, A plus B to the 3. So the good news is it's kind of easy to find the row you want because you just look for the second entry. The second entry tells you which exponent you want. So if you know you want to raise something to the power of 3, then your coefficients will be 1, 3, 3, 1. Now we're raising A plus B to the power of 6. So go directly to that row that has 6 as its second term. And you know that you're looking at 1, A to the 6th, and then 6, A to the 5th B's, and then 15, A to the 4th B squareds, and then 20, A cubed B cubes, and then notice the symmetry here. This is our middle term. So we go 1, 6, 15, then we go 15, 6, 1 down the other side. That's it, actually. We've now expanded that binomial, and we expanded it because we knew that we could just pull the coefficients right out of Pascal's triangle, and we knew the pattern in the exponents. Problem is, this all goes to heck when you have a higher power, because we're not going to want to keep building rows of Pascal's triangle. It also goes to heck when you have coefficients. What if this was 2a plus 5b, then suddenly every a term has an extra factor of 2 in it. And that factor of 2 would be raised to the 6th. 2 to the 6th is what? 64? No. 2 to the 6th is, I don't know. I think 64. But over here you'd have an extra factor of 2 to the 5th, 2 to the 4th, 2 cubed, blah, blah, blah. So all your coefficients grow and change by the powers of the coefficients in the binomial. So suddenly your coefficients are not simply the coefficients from Pascal's triangle. They involve the coefficients from Pascal's triangle, but they also involve the coefficients of the original binomial. So things get hairier. Anyway, let's try another example. So here you go. Here's an example where we've got those coefficients built in. Up here you see the general form for the expansion of a binomial. Notice the n over r. That's the NCR thing. And we talked in class about how the NCRs, those actually happen to be the entries of Pascal's triangle. I tried to teach you how NCR has a link to probability, but honestly at this point you could ignore all that. You just need to know how to calculate it. So the formula for calculating NCR was you do n factorial divided by n minus r factorial multiplied by r factorial. And so in Pascal's triangle, the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. What we're supposed to know is, again, look at that second number. See how this is a 4? So every entry in this row is an NCR where the n is 4. And what you're doing is you're from a pool of 4 things, you're choosing 0 at a time. 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And so what we know is 4 choose 0 is 1. 4 choose 4 is 1. 4 choose 1 is 4, and 4 choose 3 is 4, and 4 choose 2 is 6. So all of those entries could be found using this combination function, and that's built into your calculator. I think I'll show you how to find it now. So right here, there it comes. Yeah, there's our calculator. So to do this, you type the n that you want. So let's say I want to do 12 choose 7. You're going to type 12. Then you go into the math menu, and over here in probability, I told you it has a connection to probability, so you find it over there. So you can hit right, 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 or smart money's on just going left, left, and you can get to probability. And right there, option 3 is NCR, so press it. Oh, strange. Okay, so this calculator works a little differently from the one that I'm used to. I don't think you have to do the 12 first anymore. You can do it whenever you want. But enter the 12. I don't remember what I said. 12 choose 7. Who cares? Just hit enter. You get your answer. It's 792. So that means somewhere down in the depths of Pascal's triangle, at technically what is the 8th row, but the one whose second entry is a 12. Oh no, so the 13th row, 7 positions in, you would see the number 792. The other thing I talked about that's pretty important is when the two r values that add up to 12 will have the same value. I said that badly, but if I were to do 12 choose the hold on, math probability 3. Okay, if I were to do 12 choose the other number that adds up to 12 with 7, meaning 5, right? 5. 7 and 5 add up to 12, so they will have the same value. Look, 792, right? That's a property that you guys are going to want to be able to take advantage of. It means that we don't have to calculate as many of these because we already know them. We could do another one. Probability 3. Let's say I gave you 24. Choose 10. This should be a huge number. Not that huge, honestly. It's 1,000,000, but 1,000,000's kind of small. Hopefully, if you guys understood what I said, then what's the other value that would be the same? It'll be the other thing that adds up to 24. So 10 and 14 make 24. So if I make this a 14, I should get the exact same value. There you go. Sure. I'm going to explain the logic behind that real fast because I think it makes good sense. Again, imagine if you had 8 friends, but you could only bring 3 to a concert with you. You had 3 extra tickets. You won 4 tickets, whatever. Only 3 of them could come with you to go see BTS. So there's 56 different ways you could choose 3 of your friends to accompany you. Well, guess what? Choosing 3, isn't that the exact same as choosing 5 who have to stay behind, right? So picking 3 that get to come is the exact same as saying, all right, you 5 can't come. And so that's why those would have to be equal to each other, right? Picking the 3 that may come, there's 56 ways to do it. Well, when you pick those 3, you're simultaneously picking the 5 that have to stay home. That's why those values are always going to be the same. I'll clear that out. I'll get back to work. All right, so I think you guys now sort of have a better idea about how that NCR formula ties into Pascal's triangle. Now let's just put it to work, okay? So looking at this weird expansion, if you pick just one term at a time, the way I think about it is there's 3 parts. Every term in this expansion has 3 parts. There's the coefficient that comes from Pascal's triangle, which could either be expressed as, parentheses n over 1, or as the NCR. I prefer the NCR notation because that's what I learned first. But both notations are the same. It doesn't matter. But you're going to need that binomial coefficient. So if we're expanding something to the power of 5, then 5 will be our n. Then we're choosing, depending on what term we want. At the first term, we would do 5 choose 0. Second term would be 5 choose 1. Whatever. So let me model this. Let's do 5 choose 2. This is technically our third coefficient. So I need that. Then the next thing I need is the first term of my binomial, the 2y squared. And that'll be getting raised to, actually not the same power as this, but the complementary power, let's say. The 5 minus 2, so 3. That'll be going to the power of 3. And then the third thing I need is the second term of my binomial, which isn't 3x, by the way, because when you've got a minus, you have to include the negative as part of that term, because we're really always treating our binomials as sums. It's really 2y squared plus negative 3x. You got to think about it like that. So that negative has to get incorporated in there. Now, if this power is 3, then this power has to be 2, because the 2 powers have to always add up to 5. And this second power typically wants to match this power. Although, wait a minute, I thought we just said that 5 choose 2 is the same as 5 choose 3 anyway. So if you prefer, you can do 5 choose 3 and have this power match the first, or have this r value match the first power. It doesn't matter. But this n has to be the power that you're raising the binomial to, and then r has to be either of these. It doesn't matter which, because mathematically they're the same, right? 5 choose 3 and 5 choose 2 are the same. But this is the general form of every term. Okay, there's got to be a binomial coefficient that comes from Pascal's triangle and is calculated as a combination. There's got to be your first term to some power, and then your second term to some power. So I'm going to shut up. Let's actually do this now. Because this power is relatively low, it's only a 5, you are expected to expand the whole thing out. You know you're going to end up with 6 terms because you always get one more term than your power. And this should be doable. We know that our first term is going to be 5 choose 0. That's our binomial coefficient. Then it'll be the 2y squared to the power of 5 multiplied by the negative 3x to the power of 0. There won't be any of those. There's my first term. Now I'll add to that 5 choose 1. The r value goes up by 1. 2y squared. The power on that term goes down by 1. And then the negative 3x. And the power on that goes up by 1. And then you just keep going like that until the 4 goes all the way down to 0, and the 1 comes all the way up to 5. So the next term would be 5 choose 2. And 2y squared to the third power, and negative 3x squared. And then I've got, what, 3 more terms. So the next one is going to be 5 choose, we were on 2, so that's going to come up to 3. 2y squared. We were on 3, so that's dropping down to 2. Negative 3x, we were on 2, that's coming up to 3. 5 choose 4, yeah, these are coming up, the r's are coming up. 2y squared, that was on 2, it's coming down to 1. Negative 3x must be on 4. And then finally we get 5 choose 5. 2y squared, the 1 comes down to 0, the negative 3x has finally come all the way up to 5. So there's all 6 of our terms. They're long, so I can't fit it all in one row, but as we evaluate these, they'll get smaller, smaller, smaller. Alright, so what's the value of 5 choose 0? Well, because it's so small, we could just build out the next term of Pascal's triangle, right? And let's just do that for now, I suppose. The next term, it has to start with a 1 and end with a 1. And then all the other guys are the sum of the terms above them. So we can see 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. So we can actually see that the entries in the row that we want are 1, 5, 10, 5, 1. Now here's the thing. There is another rule that says 5 choose 0 is 1. The rule actually says that any number choose 0 is 1. And again, if you understand how this combination thing works, then I'm basically telling you, hey, you're going to go to Baskin-Robbins, there's 31 flavors, and you can choose none of them. So how many different ways can you choose no flavors? Well, you can go in and go, no thanks, I don't want any. But that's it. There's no other option. You just have to say, no thanks, I don't want any. You don't have multiple options until you're actually choosing something. And by the way, if there's 31 flavors available and I tell you you can only choose one, then how many options do you have? Obviously 31, right? You can get mint chocolate chip, great. Or you can get rum raisin, great. But you can't get Americone Dream as your ice cream if they don't offer that at Baskin-Robbins, right? So you're limited to the 31. So 31 choose 1 is 31. So, I guess that's another rule, right? N choose 1 is going to be N. That's a rule. N choose 0, well, that's just 1. That's a rule. And then we also know by symmetry that N choose N is also 1. And just to keep the analogy going, that would be like if I said, hey, welcome to Baskin-Robbins. We have 31 flavors. What do you want? Well, if you were trying to choose all 31, you'd have to say, give me all of them. That's it. That's your only combo, right? The order in which you ask for them doesn't matter. You just want them all. So there's only one way to get them all, is you say, I want them all, and then they give you all of them. So N choose N is 1. N choose 1, that is analogous to what? 31 choose 30. So how many ways could you do that? You could do it 31 different ways, because picking 30 is analogous to leaving 1 behind. If I said pick 30, you go, give me everything but the rum raisin. Rum raisin is disgusting. So 31 choose 30 is the same as 30 choose 1. It's 31. So that as a formula would be N choose N minus 1. And that would also be 1. So there's some nice formulas here. Again, what I'm talking about is basically just a rule that says the first and last things are always 1. And I'm also telling you that the second and second to last things are always the number. Alright, I don't know that if I'm talking in circles or what, but I know the 5 choose 0 is 1. I know the 5 choose 5 is 1. I know 5 choose 1 is 5. I know that 5 choose 4 is 5. So now the only ones I'd have to actually calculate if I didn't just have Pascal's triangle to look at is 5 choose 2, right? So let's pretend I have to actually evaluate it. Now I know that I already showed you how to do it in the calculator. You just go math, go to probability, option 3, 5, choose 2 is 10. We already know it. I know you can do it. But you know that on the quiz I'm going to force you to show work. So how do you evaluate 5, choose 2 showing your work? Well, you take the n value and you do factorial in the numerator. If you've forgotten what factorial is, it's the product of all the integers from 5 down to 1. 5 times 4 times 3 times 2 times 1. Now in the denominator, you want the two numbers that add up to 5. So there's 2. We obviously need the 2. And 5 minus 2 is 3. So the denominator is going to be 3 factorial and 2 factorial. Excuse me. The great news here is 3 factorial. That's going to be a 3, and 2, and a 1. And all of those factors less than 3, they're all going to have somebody to cancel with in the numerator, with the factors that are less than 5. So the 3, 2, 1 will always cancel. This whole thing will always cancel with the tail end of the numerator. Then you've got the 2, which in our case only gives us an extra factor of 2 and 1. But many of those will cancel with the remaining factors of the numerator as well. These are fun. I enjoy doing these. You cancel the 2. You're left with a factor of 2. The only thing left is the 5 times 2. There's the 10. So I would expect to see this work on the quiz when I ask you to evaluate. You can't just put it in your calculator and expect to get credit. I want to see the work where you've turned it into factorials, expanded those factorials, canceled, and evaluated. So anyway, I now know that 5 choose 2 is 10, which means that 5 choose 3 is also 10, which means I now have all of my binomial coefficients. So now let's finish this off. Drag that down, make a little room. So that means in my first factor, we've got just a 1 times. Now this is 2 to the 5th, that's 32. Y squared to the 5th is y to the 10th. But then negative 3x to the 0 is just 1. So there's my 3 factors. A 1, a 32y to the 10, and a 1. Now in the next term, we have a 5 times 2 to the 4, which is 16, y to the 8th. And then we do get a factor of negative 3. I'm going to put it in parentheses so we don't mistake it for a subtraction sign. Negative 3x. In our third term, we're getting a 10 times 8y to the 6th. Now this time, I'm squaring the negative, so it'll be positive 9x squared. So there's all 3 of our factors for that term. Next, let me just keep this as 2 rows of 3, because I'm not going to have room for all 6 terms. So this one is going to give us another factor of 10 as our coefficient. Then we'll also have a 4y to the 4th. And 3 to the 3 is going to be negative 27x cubed. Yep, and then the next one is another factor of 5. 2y squared. 3 to the 4th is going to be a positive 81x to the 4th. And then our last term will give us a 1. This thing to the 0 is now a 1. And this last term, 3 to the 5th is an 81 times 3, so 243. It'll be negative, though. Negative 243. Because it's an odd power. X to the 5th. Alright, so notice when you've got a negative term, your signs are going to actually alternate. We're actually going to have positive term, but this one's going to now be negative. So we have what? Let's switch to light blue. We're going to get 32y to the 10th. Then it's going to be minus this term. And it's what? 5 times 16 is 80, times 3 is 240. Yeah. 240. It'll be y to the 8th, x to the 1. The next term will be plus, because the minus canceled out. So this will be 72 times 10 for 720. The y value is coming down by 2, so it's y to the 6th. The x value is going up by 1, so x squared. Now we're going to get a minus sign again, so we're subtracting. Whatever 27 times 4 times 10 is. Uh, 1080. And again, we should see the y coming down by 2, y to the 4th, x coming up by 1, x cubed. So y to the 4th, x cubed. Then 10 times 81 is 810. We should be down to y squared and up to x to the 4th, and then minus 243. The y comes all the way down to 0 and disappears, and the x comes up to 5. And that is it. So there's the big old expansion of that binomial to the power of 5. We should see 6 terms. 1, 2, 3, 4, 5, 6. We do. We should see the y's starting at y to the 10th and coming down by 2. 10, 8, 6, 4, 2. Gone. We should see no x's at first, but coming up by 1, x squared, x cubed, x fourth, x to the 5th. Yep. And these coefficients, geez, I don't know if they're right. Hopefully they're right. But those binomial coefficients, the 1, 5, 10, 10, 5 one, they're buried in there. We can't really see them because of the coefficients, the 2 and the 3. They're all buried in there too. So these coefficients, we don't really recognize those Pascal's triangle coefficients. They're just worked in there as part of the final answer. All right, I hope that example was very helpful. I mean, that showed you guys the whole process. Let's do the next one. So now we're just practicing evaluating these NCR, these combination expressions. So we said 8 choose 4. That's going to be an 8 in the numerator. This bottom number is usually that second factor. And the other one is the 8 minus 4, which happens to be another 4. So this is going to be what? 8, 7, 6, 5. Then it's going to be 4, 3, 2, 1. But you know the 4, 3, 2, 1 is going to cancel with one of these 4s. So don't write the whole thing out. You might just want to write 4 factorial. Then it's going to cancel with one of the other 4 factorials. But expand the other one out. 4, 3, 2, 1. Okay, let these cancel each other out. Then be creative. You got a 4 and a 2. That makes 8. That cancels. Then you got a 3 that can cancel into the 6, leaving a factor of 2. And that's it. The only factors left to us are 7, 2, and 5. So that's obviously 70. So just in case I screwed up, you can check with your calculator. But you got to have the actual work shown by hand. So what are we doing? 8 choose 4. So we go math, probability, option 3. 8 choose 4. It's 70. We got it right. All right, 8 choose 8. Not doing any math on that. I know it's 1. That's one of our rules, right? How many ways can you pick all 8 candy bars from a pile of 8 candy bars? Well, you just scoop them all up. You can only do it one way. All right, but 8 choose 1. How many ways can you do that? Well, there's 8 of them. So you can do it 8 ways. That's another rule. In 8 choose 0, how many ways can you not take any? Well, that's 1. 8 choose 0 is the same as 8 choose 8. So this wasn't a hell of a lot of practice. So let's just do one more for the sake of argument. What if I asked you to do 15 choose 3? Well, you know that's going to be 15 factorial, which granted is really big, all over 15 minus 3, which is 12 factorial, times 3 factorial. So again, before you start going 15, 14, 13, 12, 11, don't write the whole thing out. As soon as you get to 12, you can stop. There'll be a factor of 15, 14, 13, but you know this 12 factorial is going to kill the 12, 11, 10, 9. So just leave that as 12 factorial and let it get canceled by the other 12 factorial. And then downstairs you got an extra factor of 3, 2, 1. So you take your canceling pen. 12 factorial kills 12 factorial. there's pretty much always going to be somebody that cancels with a 2. You can kill the 14, left with a 7. And usually you can find a way to cancel out a 3 as well. We've got a 15 here, leaves us with a 5. So our entire denominator is canceled, and we see that this combination, 15 choose 3, is just whatever 5 times 7 times 13 is. That's it. So 5 times 7 is 35, times 13 is, I don't know. $35 times 13 is 455. Again, just to double check. You can go math, prob, NCR, 15 choose 3. We just said it should be 455, and it is. So we got it right. And again, just for argument's sake, 15 choose what now? Would also be 455? Well, choosing 3 is the same as saying no thank you to 12 of them, right? So it would be the same as 15 choose 12. We know that for a fact. 15 choose 12 must be the same as 15 choose 3. Okay. All right. So now we have you just finding one term at a time. And thank God for that. Because if you had to actually expand something to the power of 12, there would be 13 terms, right? It would be a nightmare. So now that we understand just how to expand these things out, we typically are just going to have you find one term at a time. They're saying find the middle term. And how many terms are there? We just said 13, right? So who's in the middle of 13 things? Well, it sounds like you'd have to have 6 things over here, 6 things over here, and then 1 in the middle. And so that would be the 7th term, would it not? It would, right? It would be the 7th one. But again, remember, we start numbering at 0. So it would go 0, 1, 2, 3, 4, 5. So the thing in the middle is the thing that has 6's in its exponents. And then we go 7, 8, 9, 10, 11, 12. So you can see 0 through 5 are our 6 things. 7 through 12 are our other 6 things. And the thing whose powers are 6's, that's going to be the middle term. So why do I say all that? Well, because we know we need our binomial coefficient, which will be 12 choose not 7. It's not the 7. 7 will not be the middle one. 6 is the middle one, because that's the 7th thing when you start counting from 0. And I know that's weird. I hate that, but it's the way it is. Okay, the next factor will be the first term, the xy, and it'll get raised to the power of that number, the 6. Next, no, the other factor, negative 3x over y cubed, and that too will be raised to the power of 6. So the middle term will be the one where the two powers are the same. All right, we evaluate. What's 12 choose 6? I don't know. Should you use your calculator to do it? Yeah, probably. But do you have to show your work? Yes. So let's do 12 choose 6 over here. It'll be 12 factorial over 6 factorial, 6 factorial. That means it's going to be 12, 11, 10, 9, 8, 7. And then 6 factorial will cancel with 6 factorial. But you'll still have a factor of 6, 5, 4, 3, 2, 1. All right. 6 factorials cancel. How's about we let a 6 and a 2? Nah, bad idea. Let's cancel a 3 and a 4 with a 12. That's a better bet. Kinda. Who cares? Doesn't matter who cancels with what, honestly. Let's have the 5 and the 2 then. Cancel a 10. Whatever. What else can we do? We've got an extra factor of 6. We can cancel that with a 9. And we're factoring out 3's. So that'll be a 3, that'll be a 2. And then we could cancel the 2 with the 8 and have a 4. Okay, that got a little wild. So what do we what do we still have? A factor of 11, a factor of 3, and a factor of 4, and we never lost the 7. So the 7's still there too. So 12, 7, and 98. 98 times 11, whatever that is. At this point, you have to use your calculator. I mean, you could probably do that. Some of you can do that. 11 times 98. Enter. 1078. And there's no shame in double checking yourself. I'm going to do it just in case. So it was 12, choose 6. Was it 12, choose 6? It was. And I didn't get it right somehow. Well, that's not good. 11, 3, 4, 7. Huh. 12 times 7 is 98 though, isn't it? No? No. It's not. It's 84. Okay, I'm dumb. Whatever. I'm dumb. That's why you check yourself, people. Alright, so it's 924. Whatever. I don't care. Shut up. 924. There's our binomial coefficient. Now this is, there's no extra coefficient here. We're just going to get next to the 6th, y to the 6th. Here, geez, negative 3 to the 6th. What's 3 to the 6th? 9, 9, and 9. 81. 729, 729. And it's positive 729 because it's an even power. So you'll get 729 x to the 6th. And in your denominator, you'll have a y to the 18th. Okay, check this over 1. Check this over 1. And what's about to happen? These 6 y's will cancel 6 of these y's, so we now have only 12 y's in our denominator. Upstairs, we've got x to the 6th, x to the 6th, so that's x to the 12th. And then our coefficient is the product of the 924 and the 729. Six, 7, 3, 5, 9, 6. And we're going to need a bigger fraction bar. Okay, that's what our middle term would be. So if I asked you to give me the whole term, you'd have to include the x and the y, right? On the quiz, I'm pretty sure I never ask you for the whole term. I just say, find the coefficient of the middle term. So the coefficient is just that number. So when I ask you for that into your little field, you'll just type the 673, 596. Feel free to put a comma if you want to. I've got it programmed to accept the comma or not. It's up to you. If it's there, you'll get it right. If it's not there, you'll still get it right. That's it. That's how we do example 4. Let's move on. Where's my cursor? Here it is. Next one. So this is a funny one. It says find the term that doesn't have a y in it. So you got to think this through a bit. We're going to have this xy, right? But we're also going to have the negative 3x over y cubed. So that seems to say that when this power is 3 times bigger than this power, you'd have 3 times 1. This would be 1 times 3. You'd get them to cancel. You'd have equal y's in the numerator as y's in the denominator. Now we also know those powers have to add up to 12. So what numbers add up to 12 where this thing is bigger than this thing? Well, I guess we could say, all right, 3x and x has to add up to 12. So that's 4 x's. So x is 3. So that's telling me that if I let the first power be 9 and the second power be 3, then that'll give me the power of 12 that I need. It'll also give me 3 times as many y to the 1s as I have y to the negative 3's, and that's what will make them cancel out. So problem solved. We also need our binomial coefficient, of course. We could use 12, choose Remember, it could be the 9 or the 3. It doesn't matter. They come out the same. But this factor has to be to the power of 9. This one has to be to the power of 3, because that's how we'll get the y's to cancel out. So what does 12 choose 9? It'll be what? 12, 11, 10 in the numerator, but all the 9, 10 will cancel out. And there'll be a 3, 2, 1. So that's a 6, leaves a 2, 22, 220. Easy to calculate. This will be x to the 9, y to the 9. This will be negative 3 cubed, so negative 27, 3 cubed, or x cubed, sorry, x cubed. Our denominator will be y to the 9. And so watch now, in amazement, as our y's cancel out. And you now see this is the term that doesn't have a y in it. So what on earth is 220 times 27? 5940. So negative 5940. And we've got 9 x's and 3 more x's, so that'll be x to the 12th. So again, you were told to find the term without a y. So the whole term would have x in it. I'm not going to ask you that because I'm just not. I'm going to say, I would say find the coefficient of the term that doesn't have a y. So your answer to me is just the number. You'd say negative 5,940, and that's it. Ugh, all right. Excuse me. Not feeling great. Still, if you guys can believe it, I'll be better one day. What do we got left? I don't feel like doing that much more. 4 more? No, just 3 more. Okay, let's do them. So the next one says find the term without an x, and guess what? Yeah, no, there isn't one of those. We were able to get the y's to cancel because we had a y to the positive 1 that was getting multiplied by a y to the negative 3. So as soon as we found powers that were in a ratio of 3 to 1, we could get them to cancel out. But here we have x to the 1, and then another x to the 1. Those are never going to cancel, not for any combination of powers. If I went 12, 0, we'd have 12. If we went 11 and 1, we'd have 11 and 1 would have 12. If I went 10 and 2, we'd have 10 and 2. We're always going to have an x to the 12th. We're never going to have no x. So this one was sort of a trick question. Not a trick question. We just wanted you to think that through. So straight on to the next one. This one says find the constant term. Well, find the constant term, again, basically means find the term where the y has gone away. Right? The constant term means there shouldn't be any variable. So let's think this through. We know we'll have a 3 over y. We know we'll have a root y. Root y is y to the 1/2. Okay, great. So we know this is technically a negative power. This is a half. So we want the power here to be twice as big as the power here. Then the y's will cancel. Don't forget we need a binomial coefficient over here as well. So what values of x add up to 12? Where this one is twice as much as this one? Well, that's an x and a 2x. They're supposed to add up to a 12. That's 3 x's adding up to 12. That's an x that equals 4. So you're going to want to let this guy be 8 and this guy be 4. And then what'll that do? That'll give you a y to the negative 4th here. And it'll give you a y to the 4th here. And that'll give you a y to the 0. So they go poof. And we'll get our constant, okay? Hopefully that logic makes sense to people. So I've got the correct powers on the 2 terms. Oops, forgot the negative though, almost. We do need a negative on this. And my binomial coefficient is you take whatever the power is, 12, and we're choosing either 12 choose 4 or 12 choose 8 because it literally comes out the same either way. 12 choose 4 is the same as 12 choose 8. Okay, what is 12 choose 4? Well, it sounds like it's going to be 12, 11, 10, 9. And then 87654 will cancel with the factor of 8 factorial in the denominator. The 4 factorial will give me 4, 3, 2, 1. So do a little creative canceling. 4 and 3 makes 12, so those are all gone. And the 2 cancels with a 10 to leave a factor of 5. So can you do 99 times 5 in your head? I can't. Can you do 55 times 9 in your head? You might be able to. It's 55 less than 55 times 10, right? So 550, take away 55. Should be 495. Don't trust myself, so I'll double check. Even though I think we've already done that one today. 12 choose 4. Whatever. 12 choose 4. 495. Nailed it. Alright, 495. That's our binomial coefficient. 4 to the 3 is 81 over y to the 4th. This will be, well, there's no coefficient, so. But do recall that it's a negative to a even, so it'll turn positive. So this will just be a y to the 4th. Put that over 1 if you wish. Put that over 1 if you wish. You can get those to cancel. We wanted a constant. We got a constant. 495 times 81 is the answer. So 40,095. So that's both the coefficient only. It's also the term, right? The constant term is just the number. So we did that, and then we've got like one more. Find the term that has a 1 over y to the 17th. Fine, I will. Alright, we need our 3 pieces. Prompt. So it's going to be 16, choose something that I don't really know yet. It's going to be an x squared y to some power, and it's going to be a 1 over 3y squared. Okay, so 1 over y to the 17th. So I have to get that using some combination of a y times a 1 over y squared, essentially. Okay. Whatever. I'm not super sure how to do this. I think we have to solve a little mini. There's nothing like this on the quiz, but what do we know? If you just let this power be a, then you know this other power has to be it has to be 16 minus a. Yeah, you guys know that because they have to add up to 16. So what does that mean? This is to the power of 1. So that means a what? Forgive me. We're basically subtracting. Yeah. Let me write this out all the way. So this would be y to the a times 1 over y to the 2 times 16 minus a. And that's supposed to equal 1 over y to the 17. So at this point, they're all powers of y. So just think about the powers only. This would be a. If we're multiplying, we're adding. But if our power is in the denominator, then it's negative. So it's negative 2, 16 minus a. and that should equal negative 17. We've got ourselves an equation now that we can solve. So it's a minus 32 plus 2a equals negative 17. So that's 3a. Add the 32. Add the 32. So 32, take away 17 is 15? Yeah, makes sense. Okay, 15. So A is 5. Whoop-de-doo. Okay, there again, there's nothing like this. You guys shouldn't have to solve a whole damn equation to figure out what the powers are supposed to be. Everything's going to be a little more straightforward. Now, with that said, there could be an equation like the previous ones, like the term without a y. It was pretty easy to see that it's 9 and 3. So something like that I'm not concerned about. You guys should be able to do that. But here the math was just a little bit weird. And it's weirder than I think is fair. But now we know it's 5, so who cares? We're going to go 5 and 11 apparently. Because that'll give you 22 and 5. Yeah, that'll work. Okay, great. So now we know we're doing 16, choose 5. So we evaluate that. 16, 15, 14, 13, 12. Once we get to 11, we know the 11s will cancel out. 11 factorial is going to cancel with 11 factorial in the denominator, but we still have a 5 factorial. 5, 4, 3, 2, 1. 5 and 3. We'll happily kill a 15. 2. We'll turn, let's just do 2 and 4. That's an 8. So your 16 is now a 2. This is still too many things to multiply in your head, I assume. So what do we got? 2, 14, 13, 12. So it's that. Hopefully that's the same answer. Shoot. Excuse me. God. Alright, I gotta finish this. Okay, good. So we did have it right. 4, 3, 6, 8. Awesome. This is going to be x to the 10th. Three to the 11. Kind of dying. Sorry, guys. I know it's probably gross to listen to me, but better than nothing, maybe? Oh, good lord. 177147. 1 over. Y to the 22. Y to the 22. So that means we can let these cancel and we get the precious y to the 17th in the denominator that we needed. We have an x to the 10th in the numerator, and then whatever this is, it's probably going to reduce. It definitely does reduce. So reduce it. Put it in your calculator, reduce it. 4368 divided by our previous answer, and then just do the old math frac trick. What? Why are you stupid? Don't be stupid. Alright, that thing's being stupid. Alright, then reducing it by hand. I know that 4, 3, 6, 8 is a 2 and a 14 and a 13 and a 12. The only factor of 3 in there is a factor of 3 from this 12. So that means I can cancel one of the 11 factors of 3. So we should have a 2 and a 14 and a 13 and a 4 divided by 3 to the 10 instead. That should be our reduced form. I don't know why the calculator won't do it for us. I shouldn't have done that. So that's our numerator. 3 to the 10 is our denominator now. And I declare 1456 divided by that should be the exact same decimal from before. That looks right to me. Yeah. Alright, so even though our calculator refused to do the reducing, I did it myself. It's 1456. Over whatever 3 to the 10th was. So 59049. And I wrote that ugly, so let me clean that up. 1456 x to the 10th all over 59049 y to the 17th. Easy peasy, right? Super simple. Alright, there's nothing like this on the quiz. Don't worry about it. Your quiz is going to be a little more straightforward. So what will the quiz be like? You better understand Pascal's triangle, how to build it. You better be able to build it by hand. You better understand that every entry is just the sum of the other entries above it. You better be able to find individual terms by just understanding that they are combinations. So our next row would start with a 5, right? So this must be 5 choose. Where am I? 1, 2, 3. It's the 4th, so it's whatever 5 choose 4 is. You better understand that connection. You better understand how to take these binomials and expand them all the way. You better be able to find each individual term. But that's your quiz. So you got Monday and Tuesday to talk to me, but this thing's due Tuesday night. Okay, so you can ask me questions Monday and Tuesday, but you got to get it done by Tuesday night if you're taking it. All right, I hope that helped. I'll talk to you Monday, Tuesday. Bye, everybody.